So now let's begin with the simpler concept, division. Yeah, never mind the simpler concept. Let me settle in your own mind right away why division with remainder is not an operation. As we said, operation means given two numbers, you want to come up with another number, right? One number. So 25 divided by 4 is not an operation because what number you get? You want the quotient or the remainder or both? Either way, it's not going to work. Right? You come up with a quotient and a remainder. That's not one number.
One.
I'm sorry?
No, it's not a whole number.
It's not one number.
Two fractions.
Quotient and the remainder is not one number.
No, I agree with that.
Okay, so that's
Yeah.
what I'm saying.
Yeah.
Therefore, division with remainder is not what we call an operation. Okay?
All right, so in the context of my classroom, if I've got those candies or cookies that I'm dividing up among my 8 children, and I could have 24, in which case then it is an operation, or I could have your 27, in which case it's not. And so at what point is that semantics as far as dealing with it in a real life situation with my children and notating it?
In a real life situation, if they all get their candies, they don't care.
But if I want them to write down a procedure that will get them an
That's different. You suddenly shift gear to mathematics.
Right.
Then it's your job to be as clear as possible and explain to them. Right now, I'm introducing to a concept where I give you 2 whole numbers. Right? You can divide one into the other and give me something called a quotient, which is sort of roughly speaking, well, we have to explain that later. And then something called remainder. So that's that tell them this is something you can do with any 2 whole numbers. Doesn't matter. Give me any 2 whole numbers. I can give you the division with remainder, tell you exactly what the quotient is, and exactly what the remainder is. But you want to do division? It doesn't matter.
So this is division with remainder as opposed to division.
Yes.
Okay.
There are 2 distinct concepts, and you should keep it firmly in mind. And you can instruct your students from the beginning that there are 2 distinct concepts. You're going to save them a lot of trouble in the future. You'll save yourself a lot of heartache explaining the unexplainable. All right? So what these things are going to unfold, and then you have more questions. We're going to settle all of them. Okay, let's start. So without going into details, you understand why division with remainder is a completely different animal from what you like to call division. Division to you is what? Usually equal groups, or what we call measurement, right? 24, later. I don't want to muddy the water. So let's do the simple concept, division. You might find that interesting. Given 2 numbers, (48) and 16. We say 48 divided by 16 is the number k, so that 48 is equal to k times 16. That's clear cut, right? Now the only reason I write this down is yesterday we did subtraction, right? Let's look at subtraction. 48 minus 16. What did we say it was? It is the number k, so that I forget now. Let's get it. K plus 16 is equal to 48. Or write it out. No, I want to emphasize 48. Okay. Sorry. That's the way I hope that was the way I wrote it. Now you see the similarity, yes? As I said, it's really a higher level of abstraction. Of abstraction. What is it? Abstraction, right? Normally you see, you add two numbers. I say the sum of two numbers is what? It's very straightforward. Concatenate and measure. Forget it. Multiply. Well, that's even simpler. Add that many times, you're done. But for subtraction, I can't say that. I'd say you find out for yourself. Are you getting the right answer for this? Well, do it. Do the arithmetic. Same thing here. I can't tell you what this is. You have to find out. Multiply. See what happens. So does one work? No. Does two work? No. Three? Oh, we're in luck. It works. So that's it. Now, by the way, I want to do clicker. Can I do clicker? I want to say this definition, 1. Only 2. Oh, yes, sorry.
May we have a third option that says neither?
Neither.
Thank you.
Yeah, let's close that and we'll start again.
Makes sense. Ready for us?
Yes, go ahead.
Thank you.
Yeah?
Do you mean, is it strange to me personally or strange to like the textbook?
To you.
Just strange in general?
Strange to you.
Okay. Wow.
Neither. Okay. Since the majority opinion, I'm sure people will not hesitate to explain why is it neither. You don't think it's strange? You don't think it's commonplace? What is it? It's both strange and commonplace. Okay, Amy, you want to explain why do you think?
Sure. I said neither because that's what you have written there is my understanding.
Neither strange?
So it doesn't seem strange to me. But I don't think that it's used commonly. I believe that when people talk about division, they talk about the grouping concept instead of an indirect
Oh, now you what grade you teach?
high school.
Okay, so Anyone teaching grade 4, grade 5? Grade 4, grade, oh, no wonder. No wonder statistics is so skilled. Fourth grade teachers and fifth grade teachers would all have said number 2. It's absolutely commonplace. We don't believe it. I tried on you.
Oh, yes, I do say it all the time. What times this? What times 8 will give you
What's the answer?
all the
What's the
time?
answer?
Right, 4.
What's the answer? Well, how do you know it's 3? Oh, you don't say that every day?
Yes, we
You
do
do
say
say
it
it every
every day.
Right? Don't you call it commonplace?
I call it
It's commonplace. That's exactly what you tell people how to divide.
You don't look at it like that, but it is exactly right.
That's exactly. But of course, this only happens for 4th and 5th graders and up because only at that point they divide all the time. But when you just introduce the concept itself, it's it's equal grouping, whatever. That's why I said if there were 4th and 5th graders teachers here, they would immediately say, all right, you all go back to 4th and 5th grade and learn something. That is commonplace. This is exactly, you may not be aware of it, but this is your working hypothesis about what division is. Because in everyday life, you don't think about equal group. You just say, divide and get over with. Right? Okay. So now, so I hope it makes you understand that this is entirely natural. That's exactly how one thinks about division. You say, what is it? Well, you just multiply it and see what happens. See?
But is it supposed to say whole number?
It's only for whole numbers. So we're only for whole numbers. No, I mean, this way of thinking. It's commonplace, entirely commonplace. And what is not known is that this commonplace thinking is valid for all numbers, no matter what. Rational, irrational, complex, whatever. And that is the proper way to understand fraction division. But that's later. Next week. Coming at chapter. So this is our official definition of division. Now, of course, I cannot just leave it at that, right? So what is at stake here? Of course, I chose my numbers properly. This has been pre-chosen to be a multiple of 16. Right? So you want the official definition. Given two numbers, m and n, so that m is a multiple of n. That is the precondition for division. Then, by definition, m divided by n is the number k, so that m is equal to kn. Oh yeah, I did not make it official, but I did it in the book, but I forgot I should do it here. When we have specific numbers, we always put the cross multiplication here, right?
Oh, yeah.
But when we have just letters, then we ignore that sign, and because that's easy to confuse with the letter X of them. So that's why instead of saying K cross N, I just say K. K cross N, K N. That's nothing to that. That's just convention. Convenience one. Now, so this is what division is very restrictive among whole numbers. You can see that, right? I give you 5 and give you 12. You can't divide. not 5 by 12, not even 12 by 5, doesn't matter. So it's a very restrictive operation. So keep that in mind. When you talk about division of whole numbers, you have to make sure that one thing is a multiple of the other before you can talk about it. All right? Now, even so, there are certain things in life, that don't appear too often, but when they do, you pay a lot of attention to, right? Such as an earthquake. So this one, all those two. Does it happen? No, but that's a fact of life. Yeah. It may not be often, but it's very interesting. You should be alert and pay full attention. You don't agree? That's the idea. Just because it doesn't happen often doesn't mean that you should just say, oh yeah, that is lie. No, it's not true. It's very interesting. Right? Suppose we have a situation where we can divide. It so happens that this can be interpreted differently. The different interpretation, you all know, now there are different names for this, but the name I prefer is partitive and measurement. What's that mean? So notation as, this is very awkward. If I use concrete numbers, it really has no meaning. I don't think I can do it. I mean, no, you see, this is already very awkward, You see that, right? That's silly, the way I've stated it. Why do you use k? You know perfectly well it's 3. So I can't use this. I have to use some symbols. I hope you understand. Okay, so with this understood, I'm going to explain to you what's meant by the partitive interpretation, what's meant by the measurement interpretation. Right? Partitive means m minus n is the number of equal groups when m is partitioned. I want to avoid the word divide, all right? Into n equal groups. Sorry, I wrote something wrong. You know that, yeah? That's not number of elements in each group. Number of objects in each group. And the partition of the n equal groups. That's the meaning of partitive interpretation of division. The measurement division. Okay, let's talk about this first. So, now we use 48 and 16, right? Oh, that's too big. Let's say 18 and 6. So the partitive meaning, right? Means I have to divide 18, right, into 3 equal groups, 6 equal groups. And I ask, how many are in each group? That's easy. Okay, you see, right? 18. Here you have 6 equal groups. And so 3 in each. No question. So in this case, this is called, of course, you all know, I don't want to bother you with things like that, right? That's called a divisor. The divisor tells you how many equal groups you want to divide this collection of objects. That's what's called partitioning. You're partitioning 18, or in terms of number line, okay? Number line. Then what it is you're asking how big is this? There's 6 here. So 1, 2, 3, 4, 5, 6. 6 equal segments. And just say how long is each segment. Right? Now it's confusing. Now especially you're not taught elementary school, you probably take it for granted and you don't want to be bothered and so on. But when you think about it, it's somewhat miraculous that this is. Now, of course, there's nothing miraculous about this, but I mean, what's coming next is somewhat miraculous. What is measurement interpretation?
How many groups? Groups are of a certain size.
Is the number n divided by n is a number of groups. When
Yeah.
when m objects are broken up into, I'm using language to avoid confusion. You don't have to be that dramatic. Broken up into groups of size n. All I want is to convey a certain message, and you know exactly what it is. So you don't mind all the broken up into and that kind of thing, right? But just want to make sure that you don't misunderstand. Now look at it. Don't look at me. Look at this. The two things look completely different. Sorry?
So your partitive objects can be any size.
You don't know what it is.
Yeah.
You just divide into equal groups.
Into equal groups, like you said yesterday, we were all different weights and heights, so we could be divided partitively and we're not necessarily equal.
I don't think you divide as partitively
One,
in equal
you're
groups in height. You'll have 23 people here, then you have 23 groups.
So one it tells you how many groups you break it into, and the
No,
other
but
one's the
tells me how many
size.
groups we break into, yeah.
And the other one's
But
the
they
size
would
of
be
each
equal
group
to
that you
the
break it
size
into.
of
and
the
how
Equal
many
height,
would
you know,
be
that's almost impossible.
given a size.
We actually had this debate in class of like, if the 18 things were candy, they don't all have to be the same candy. You know, they could be jelly beans and M&Ms, and you're still
But then it's
dividing
not a unit.
18 of them into groups of 3.
Well, you specify. I mean, in this case, quality doesn't matter. It's the size. That's the only thing that matters.
They
So
don't.
if you have orange, you have oranges and apples. You don't say divide into the apples into equal group. You say divide the fruits into equal groups, right?
Right.
So that you have to be careful. But that is sort of, you have that kind of common sense. I'm not going to bother you with things like that, right? But do you know why the two? Okay, now look at this. I'm saying either way will give me the same answer. Why is that? What is the underlying reason? Do you know?
Because
that's
they're still looking for another factor that when multiplied by n will give you
Yes,
n.
but why should that be the same as the other? That's the
Because there's
question.
only one number that when multiplied by n will give you m.
But what do you call that? What's the underlying reason? You still
Community property.
is commutative property of multiplication. Let's go through it carefully. All right? Let's go through it carefully. Right? Sorry?
Do we have time to do that?
Oh yeah. So maybe keep you in great suspense. The dying to find out, so you come back early.